This is AQA A-Level Chemistry. It's a multiple choice question on the topic of Equilibria, specifically Year 13 and the unknowledge of Kp. It's a very big question. I'm going to recommend you pause, take your time working through it, and then review. So as I've already alluded to, there is a huge amount to do to get to the final answer in this question. The start point is to work out the equilibrium moles. Now, if I draw the table out, you can see that we've got initial moles, equilibrium moles for each of the three. And the first part's relatively simple. We know we had 2 moles of each of the reagents. We started with none of the products. The problem is we've not been told how many equilibrium moles there are of any one individual. We only know what the total amount of the 3 gases is, that's 3.4. So we're going to need to do this algebraically. Now, if I say that the number of equilibrium moles of SO3 is X, I can then follow that through and say that the number of equilibrium moles of SO2 will be 2 take away X, because 1 mole of SO2 makes 1 mole of SO3. Slightly more complicated, 1 mole of O2 makes 2 moles of SO3, so the number of equilibrium moles of O2 will be 2 take away half an X, or X over 2. So we've now got this mathematical expression with all of the X's, and we know that the sum of all of these is 3.4. So 2 take X plus 2 take half X plus X is equal to 3.4. If I then rearrange it to put all of the X's on the same side, I have negative X take away half X plus X equals 3.4 take away 4. Simplifying all of that, negative half X is negative 0.6, which means that X is equal to 1.2. So I now know that I have 1.2 equilibrium moles of SO3. But I'm still not at the end of the question yet. Some people might stop and put the answer D. There is still more to go. We want the mole fraction. The mole fraction is going to be 1.2, the number of moles of SO3, divided by 3.4, the total number of moles of gas at equilibrium. When we do that, we get to an answer of 0.353. Correct answer is B.